A piercing alarm cuts through the pre-dawn quiet of a New Jersey port. Red lights flash across the side of a massive refrigerated container truck, a silent scream against dark steel. Alarm lights flash urgently. Inside the cab, Sal stares at a small digital screen. The number on it is climbing, 34.7 degrees Fahrenheit, 35.1 degrees Fahrenheit. The digital thermometer reads 35.1 degrees Fahrenheit. A clock on the dashboard ticks with brutal honesty. It's been 8 minutes since the primary cooling unit failed. He has about 20 minutes total before it all goes sideways. 20 minutes of a power outage, a simple mechanical failure, stands between a perfectly executed plan and a mountain of waste in a sealed 40-foot reefer. This isn't just a number. It's a countdown to disaster. Inside that steel box, about 45,000 pounds of chilled beef primals and trim, $225,000 at $5 a pound. 10 million ground beef servings, boxes and cartons in the cold hold. Origin, sun-drenched cattle ranches of Brazil, trim and primals destined for grinding. Transport, over land, transport, over sea, bound for the United States to be ground into retail ground beef. 180,000 quarter-pound burgers, say it out loud. 45,000 pounds becomes 180,000 servings, a number so big it blurs. So let's make it real. Picture a stadium at capacity. Everyone gets a burger, then another right beside it, and there are still thousands left. That's what a single massive shipment can serve, one cold box feeding entire cities. It starts on Brazilian ranches, cattle that become primals and trim bound for grinders. Dozens of 40-foot reefers line up, sealed, sensor tracked, temperature verified, stacked like frozen Lego bricks on a northbound hull. This isn't just food, it's choreography at industrial scale. A route traced from Brazil to U.S. ports, then inland to grinding plants. Bookings, customs, telemetry, a global nervous system that moves cold. Primals are boxed, trim is bagged, frozen or tightly chilled to spec. From ship to reefer trucks to hubs to U.S. grinders, the burger's cold path home. Let's start at the end, the bright ground beef case, and work our way back. You see trays of coarse ground beef, the ridges pressed by the grinder die. Labels read 80-20 or 90-10, blends set by fat ratio, not guesswork. Now peel back the layers, an autopsy of the cold chain. That display case is refrigerated, bathing the meat in air just above freezing. Behind it is a walk-in cooler where boxed chubs wait for the butcher. Before that, a refrigerated truck rolled up to the dock with cases of ground beef and primals. Step back again. A U.S. grinding facility minces trim, blends to target fat ratios, and packs it into chubs or patties under strict QC. From there, pallets move to a regional distribution center that stages store deliveries. Further back, beef trim and primals arrived by ship, sealed in a 40-foot reefer. Each layer is another shell, guardians of the cold that buy time. What's happening inside that 40-foot steel reefer? It's more than insulation, an active machine managing airflow and temperature. At one end, the unit pulls warm return air across evaporator coils. As refrigerant evaporates, it absorbs heat. Baffles drive a controlled loop of cold air front to back. Sensors and data loggers watch every degree while compressors push refrigerant through the coils. As the refrigerant expands, it strips heat from the return air. Then it's compressed and rejects that heat through the condenser outside the box. The cycle repeats, extracting warmth and holding a narrow set point all the way home. It's easy to take for granted that beef raised an ocean away can arrive safe and cold in the United States, ready for grinders and grocery cases. But for most of human history, distance meant decay. Fresh meat spoiled, fast. The first workaround was ice, blocks cut from frozen lakes, packed with sawdust to slow the melt. Insulated rail cars and ship holds followed, rolling and floating ice boxes fighting the sun. Cities could only grow as large as nearby farms, and slaughterhouses could feed them. Then came mechanical refrigeration, ammonia compressors and coils that made cold on demand. The market exploded beyond the local. Populations swelled as perishable food could finally travel. Linked cold rooms, chilled rail cars, and cooled ship holds formed a new system, the cold chain. Today, the reefer container perfects that idea. Sealed steel, active cooling, and sensors watching every degree. That's how beef from Brazilian ranches can cross the equator and arrive at U.S. ports still safely cold. Much of it is destined for grinding, strict temperature control enabling steady supplies of fresh ground beef. From carcass chill to container to shoreside cold rooms, the box must stay in the safe zone. Deep insulation, tight doors, and steady airflow buy precious time against encroaching heat. In the icebox era, melt always won. With reefers, time is managed, risk pushed back mile after mile. Still, the margin is thin, lose power, and the countdown begins. Ice would melt. The modern cold chain must not, because millions of safe meals depend on it. You don't just build a multi-million-dollar refrigerated container and hope for the best. You have to torture it. You have to push it to its breaking point to know where that point is. Before a new model of reefer is ever allowed to carry a real cargo, it is put through a brutal gauntlet of stress tests. Inside environmental chambers, under watchful QA teams. Engineers simulate the worst conditions imaginable. They bake it under heat lamps that mimic equatorial sun. They blast it with wind and salt spray to simulate a storm at sea. They shake it violently on vibration rigs to replicate rough roads. The goal? Find weaknesses before a $100,000 cargo does, before QA signs off. One of the most critical trials is the power-off drill. In a controlled chamber, the team cuts all electricity to the cooling unit. Then they start a clock. The container, loaded with dummy beef primals and studded with thermaloggers, must prove it can hold a safe temperature. Long enough for a driver to notice a problem. Long enough for a ship's engineer to swap a generator. Long enough for a backup to kick in. Its insulation must hold the line against the encroaching warmth, buying minutes for human intervention. If temperature rises too quickly, the design fails, and those beef primals won't reach U.S. plants within spec to be safely ground. One animal, under a Brazilian sky, our story begins on grass, raised on open pasture, managed by ranchers who read the land like a map, harvested, inspected, and quickly chilled to lock in safety and quality. Primals and trim are boxed, barcoded, and sealed. Pallets roll into a 40-foot reefer. Sensors and data loggers come online. Truck to port, crane to deck, part of a steel city at sea. Generators hum across the Atlantic. Temperature trails streaming to shore. U.S. port, customs cleared, USDA stamps the paperwork and the cold moves on. The boxes head to a federally inspected grinding facility. Trim drops to augers, pushed through spiral shafts and grinder plates. Batches are blended to targets, 80-20, 90-10, precise fat ratios. Metal detectors sweep every line. Data and samples verify the lot. The mince is quick chilled back to safe range before packing. Then portioned, 1 to 10 pound chubs or patties, vacuum sealed and tight. Labels print, dates code, cases stack. Pallets are wrapped, scanned, and loaded into outbound reefers. Miles later, a supermarket case, cold, safe, and ready for dinner. From grass to glass, an unbroken cold chain, measured in minutes and degrees. So what's next for this invisible essential network? The cold chain of the future will be smarter, leaner, greener. Driven by data, IoT sensors stream box temps and GPS, feeding live dashboards that flag risks early. Lot-level blockchain and automated grinding verify fat ratios in real time. New refrigeration units sip power yet pull hard, with efficient condensers and variable speed drives. And they switch to low GWP refrigerants, coolants that protect food while slashing climate impact. The industry is moving toward electric trucks, hydrogen-powered trucks cutting diesel roar and clearing city air along the route. Thermal cameras and core temp probes watch the product itself. Their insulation, more advanced, so steel boxes hold the cold longer, and fewer shipments and stakes are lost. Logistics is the invisible heartbeat of our civilization. If you want to go deeper into the machines, the systems, and the global arteries that power our world, subscribe, now turn on the notification bell. Join the network. Like this video to help the algorithm map our reach across the digital grid, and we want to hear from you. Comment below what's the most complex supply chain you've encountered, or tell us which industrial marvel we should deconstruct next. The system only works if we understand it. Stay informed, stay ahead.